Good morning, students. We will start in 2 minutes. Our lecture.
Yes, ma'am.
Good morning, ma'am.
Good morning.
Good morning.
Good morning, ma'am.
All of you have received the timetable for INSEM exam, right?
Yes, ma'am.
So 30th is our paper, and it will be theory paper. So start preparing, and the first 2 units will be there in the INSEM exam. Okay, so we'll start with the lecture. The first topic, let's just revise what we did in the last lecture. We had started with Euler theorem, and it was for homogeneous function. What do we mean by homogeneous function? It's an expression wherein the degree of each of the term in the expression is same. If it is polynomial by polynomial, then degree of the numerator minus degree of the denominator will be the degree of the entire expression. Numerator minus denominator degree will be the degree of that particular homogeneous function. And if the function is homogeneous, then Euler's theorem states that the first order partial derivative of some specific form is equal to a fixed value, and second order partial derivative is also of some fixed value. So let's just revise that. What is that statement? If U is homogeneous function of degree n, then x dy by x plus y dy by y is equal to n into u. This was the statement for first order partial derivative by using Euler's theorem. Second order formula was x square uxx plus 2xy uxy plus y square uyy is equal to n into n minus 1. This we can prove with the help of first order equation. Okay, but in this case, u was directly homogeneous. U was directly homogeneous. Now, in case your function u is not homogeneous, but it is function of a homogeneous expression. So, what is the meaning of that? Let me just tell you. Suppose z is equal to f of u. Z is equal to f of u, where z is equal to f of u is homogeneous of degree n. Now, who is homogeneous? Z. But what is Z? Z is function of u. Okay. So this, if it is homogeneous function, then what will be the expression? The Euler's theorem states that x dy by u by dy x plus y dy by u by dy y. Left hand side is same because we have to present to the u as the function who is actually becoming homogeneous, function of a homogeneous expression. So x dy by u by dy x plus y dy by u by dy y. Now it won't be just nu because u is not directly homogeneous. F of u is homogeneous. So here it will be n into f of u by f dash of. Please note the change. What is the change? Here, when u was directly homogeneous, we had n into u. Now u is not homogeneous, f of u is homogeneous. Then your expression x dy by u by dy x plus y dy by u by dy y is equal to n into f of u by f dash of u. N into f of u by f dash of u. I'll prove this in short quickly so that you can understand. And then using this, we can prove the second order. So just see now, who is homogeneous? F of u is homogeneous. Means Z is homogeneous. If Z is homogeneous, by equation 1, x dy by z by dy x plus y dy by z by dy y is nothing but n into z. This is from 1. Yes, is this clear to everyone? Z is equal to f of u is homogeneous. Then applying the Euler's theorem for direct homogeneous function, we get x deba z by deba x plus y deba z by deba y is equal to nz. Okay, but what is z? Z is f of u. So what will be deba z by deba x? Deba z by deba x will be deba by deba x of f of u. Deba by deba x of f of u. That means f is a function of u and u inside has x. U inside has x. Otherwise, this equation does not have any meaning. That's why it will be a chain rule here. Function of function. This will become deba. What is it? Your function will become deba f. That is derivative of f with respect to x means f dash of u into deba u by deba x. You are differentiating f with respect to x. So first I have to differentiate the function f, which is f dash of u, and then I have to differentiate the internal function u with respect to x. Is this statement clear? Then everything is very easy. Differentiating f of u with respect to x means first find the derivative of f. What is the derivative of f? F dash of u. And what is then the derivative of u with respect to x? Deba u by deba x. Is that clear? Everyone? Deba u by deba x?
Yes, ma'am.
Yes.
Okay. Okay. So this is nothing but deba z by deba x. So tell me what will be deba z by deba y? Deba z by deba y will be deba by deba y of f of u. That is nothing but again f dash of u into deba of u with respect to y. Differentiate u with respect to y. And therefore, now you put this in equation 2. Therefore, equation 2 becomes x into what is deba z by deba x? F dash of u into deba u by deba x plus y into f dash of u deba u by deba y. And that is equal to m into z. But what is z? F of u. And therefore, f dash of u is common. So x deba u by deba x plus y deba u by deba y is nothing but n into f of u divided by f dash of u. And obviously, f dash of u will be non-zero. Is this clear, everyone? That's the proof. Yeah. Yes. What has happened? Is the statement clear to everyone?
Yes.
Yes.
Yes, ma'am.
Yeah. So you got that x deba u by deba x. Just a second. Why only? I think only C division students have joined. D division students could not join. Just a second. You wait for 2 minutes. Now they have joined. Okay, so let's continue. What is z is equal to f of u is a homogeneous function of degree n. Then we have the formula, revised formula for Euler's theorem as what it is? What's the formula? The formula is x deba u by deba x plus y deba u by deba y is equal to n into f of u by f dash of u. This statement will be directly asked for 1 marks, and applying that we will get the answer in, maybe they'll give you the statement and they'll ask you what's the value, or they'll ask you directly what's the value of this particular function. So that you have to use n into f of u by f dash of u. When you are going to use this formula, if z is equal to f of u is homogeneous and not u. If u is directly homogeneous, the first formula you are going to use. If f of u is homogeneous, you are going to use second formula. Is this clear? So I have proved also how we get it. And second order formula for homogeneous function f of u will be obtained from this only by differentiating it once again. And that formula turns out to be x square delta square u by delta x square plus 2xy delta square u by delta x delta y or delta y by delta x plus y square delta square u by delta y square. This is nothing but equal to g of u into g dash of u minus 1. Where what is g of u? G of u is nothing but, I am writing it here. G of u is what you have got from the first order Euler's theorem. That is n into f of u divided by f dash of u. This is the first. Is it okay? So please write it down. What will be the statement? If z is equal to f of u is homogeneous of degree n, if z is equal to f of u is homogeneous of degree n, then x delta z delta u by delta x delta u by delta x plus y delta u by delta y is equal to n into f of u by f dash of u. N into f of u by f dash of u. Is that clear? N into f of u by f dash of u.
Ma'am, can you please repeat?
I'll repeat. If z is equal to f of u, is homogeneous function of degree n, I've written it on the board. Z is equal to f of u is homogeneous of degree n, then x delta u by delta x plus y delta u by delta y turns out to be equal to n f of u by f dash of u. What's the difference? If u was directly homogeneous, the answer was n. But now u is not homogeneous, f of u is homogeneous. So in place of u, you write f of u. And since f is there as a function, when I am differentiating, derivative of f will also come on left hand side. That will be taken on right hand side in the denominator. So that is the proof is given there. Z is equal to f of u is homogeneous of degree n. Then by the first theorem, Euler's theorem, you have x delta z by delta x plus y delta z by delta y is equal to nz. But what is z? Z is f of u. So what's the derivative of z with respect to x? Derivative of f with respect to x. That means first you have to take the derivative of f, that is f dash, into derivative of u with respect to x, because it's a chain. Z is depending on f and f is depending on u, which is in turn depending on x and y. So f dash of u into delta u by delta x. Is this okay? Then similarly, you get delta z by delta y to be partial derivative with respect to y of f of u. That is f dash of u into delta u by delta x. We did that function, that example last, which was function involving function x square minus y square into f of xy. There also what we did, we first differentiated f, that is f dash, into derivative of xy. Here we are doing the same thing. Since z is f of u, first I have to take the derivative of f, which is f dash, into delta u by delta x. So I got the value of delta z by delta y, delta z by delta x, substitute in 2. Your equation 2 will become x into f dash delta u by delta x plus y into f dash into delta u by delta y is equal to nz. But what is z? Z is f of u. Therefore, this will be our expansion. Now, f dash of u is common, so take it out and then take it on the right hand side. It will go in the division, and that's why the formula x delta u by delta x plus y delta u by delta y is n into f of u by f dash of u. Differentiating this one more time, you will get a second order Euler theorem for z is equal to f of u to be homogeneous, which will turn out to be x square uxx plus 2xy uxy plus y square uyy will be g of u into g dash of u minus 1. What is this g of u? It is the expression which is obtained from first order, because I will be differentiating this to get the second order derivative. Multiply with x, multiply with y, and then add it up and you get the answer. So I have to differentiate this side. That's why I am calling this as g of u, and the differentiation is going to be g dash of u. Minus 1 comes from left hand side. You are going to get g of u again on left hand side, which will come this side as minus of g of u. Therefore, this will be our answer. Is this okay? Clear, everyone?
Yes, ma'am.
Yeah.
Yes, ma'am.
Fine. So we will do examples on this because look at the expression, they are quite big. Second order derivatives are there, first order derivatives are involved, and you will be able to get the answer within no time because you know the entire expression is just either, if it is directly homogeneous, nu and n into n minus 1. If it is f of u is homogeneous, then it is n into f of u by f dash of u, or g of u into g dash of u minus 1, where g of u is n into f of u by f dash of u. All these statements will come for 1 mark, so you should know them thoroughly. Read the statement properly, whether u is homogeneous or f of u is homogeneous. Depending on that, you will be having the right answer. Okay, fine. So once again, we'll write down all the statements of Euler theorem together. Take down Euler's theorem. 4 Euler's theorem you can write down. So first one is, you write down, if u is homogeneous function of degree n, if u is homogeneous function of degree n, then xux, how will you write it? Xux. I'm revising it again and again because you should be knowing when to use which formula. Okay? I'll write down all the 4 formulas and then we'll see the examples of it. Xux means del by u by del by x plus y is equal to n into u. This is the first one. Second is x square uxx plus 2xy uxy plus y square uy is equal to n into n minus 1 u. This is equation 2. This is the answer where u is homogeneous of degree n. And if z is equal to f of u is homogeneous of degree n, then xux plus yuy, left hand side remains same, but right hand side becomes n into f of u by f dash of u. And second order, x square uxx plus 2xy uxy plus y square uyy becomes g of u into g dash of u minus 1, where g of u is n into f of u by f dash of u. N into f of u by f dash of u. This is third and this is fourth. Now when I am saying g dash of u, that means I am differentiating with respect to u and not with respect to x. Is that clear? G dash of u means I am differentiating with respect to u. So again, del by u by del by x should not be written directly, that we have taken all the things on left hand side and got this answer. So g dash of u means suppose you get 10 of u. 10 of u is your g of u. Then what will be g dash of u? Sec square. Derivative of tan theta.
6 square theta.
Okay? Clear? Again, you are not going to write del by u by del by x because the derivative is with respect to u. If it was not, I would have mentioned del by x of g of u. It's not like that. It is del by u of g of u. So g dash of. Okay? So we'll take the examples now. First two type, we have taken some examples. Now let's see the second type questions. Okay? Take down. If u is equal to log of, let's start with an easy question and then we'll go to the difficult one. If u is equal to log of x cube plus y cube, if u is equal to log of x cube plus y cube minus 3x squared y plus xy squared plus xy squared, then value of x ux plus y uy and x squared uxx plus 2xy uxy plus y squared uyy is. That's a question. What are these two equal to? Generally, when it was theory paper, they used to ask to prove it. But now they will ask you what's the value and they give you the options. So we'll have to see whether this is which type of function. First of all, how will you identify that it is a question of Euler's theorem? Whenever the expressions are of the type x ux plus y u r or x square ux plus 2xy xy plus y square u y, that means you have to use Euler's theorem. Is that clear? That's the most important one. So we have to first identify when I am going to apply Euler's theorem. It totally depends on the expression which is asked. So here both the expressions are of Euler's theorem. That's why we will go for Euler's theorem. Second thing that you have to check is whether u is directly homogeneous or it is not a function of homogeneous function. It is a function of homogeneous expression. Now look at the question. What is your function u? Your function u is log of x cube plus y cube minus 3x square y plus xy square. So the expression inside the bracket, everyone is having degree 3. 3, 2 plus 1 is 3, 1 plus 2 is 3. So this expression is homogeneous. But what's the degree of it? It's 3. So I cannot write x cube outside log. When do we say a function is homogeneous? I should be able to write directly u as x to the power n into some function of y by x. So here you can be written as log of, I can take x cube common, but it will be not outside log. Is it okay? This x cube cannot be written here. Can you see everyone? That's why I have to take this log on other side. So it is not directly homogeneous. If I want to take log on the left hand side, what should I do?
E raised to u.
E raised to
Yes, take anti-log. Isn't it? If I want to remove log, I have to take anti-log. So what will happen? E raised to u will be x cube into some function of y by x. I won't write written f no. So I write here f. So e raised to u x cube into f of y by x is homogeneous. Of degree 3. Is this okay? E raised to u is homogeneous and not u. Therefore, it is of type 2. So f of u is e raised to u. So first write down that, and then you know directly what the formula is, you get the answer. So your function now is f of u is equal to e raised to u. Now if you are getting confused with this f and that f of u what I have written, you can write e raised to u is equal to x cube into f1 of y by x. So e raised to u is f of u. Okay, and this is homogeneous of degree. This is homogeneous of degree 3. So by Euler's theorem, x ux plus y uy is equal to n into f of u by f dash of u. So what is n? N is 3. What is f of u? E raised to u. What is f dash of u? Derivative of e raised to u is e raised to u. So e raised to u cancels and your answer is 3. Now you have to find the second order derivative. So x square uxx plus 2xy uxy plus y square uyy is nothing but g of u into g dash of u minus 1. But what is g of u? This 3 is g of u. And therefore your answer is g of u is 3. What's the derivative of 3 with respect to any variable? 0. Minus 1. That's why our answer is minus 3. So this answer is minus 3 and this answer is 3. Is it okay? Everyone? As simple as that?
Yes, ma'am.
Okay?
Yes, ma'am.
So now, since I wanted to show you how you get it, I have written all the steps. In your MCQ exam, directly you can see that this is a polynomial of degree 3. I have to take e log on this side, that means I have to take e raised to u. Derivative of e raised to u is e raised to u, it cancels. So value of first order derivative will be 3. Second order derivative of 3 is 0. So 3 into 0 minus 1 minus 3. That's it. Within 2 lines, you should be able to write down that answer. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, okay. So we'll go to the another question. Any doubt to anyone?
हा मॅम.
Yes, please ask.
मॅम आपण डायरेक्ट नाही घेऊ शकत का N3 कारण की वरचे डिग्री तर सगळे होमोजिनियसच आहे ना.
काय करू शकत नाही डायरेक्ट?
N3 नाही घेऊ शकत का एवढं सॉल्व्ह करण्यापेक्षा कारण की
N3 हो ना, ठीक आहे ना, N3 च आहे, डिग्री 3च आहे, पण कोणाची? U ची डिग्री 3 आहे का? तेच तर सांगितलं मगाशी. U ची डिग्री 3 आहे का f of u ची डिग्री 3 आहे?
U ची डिग्री 3 आहे ना.
कशी काय U ची डिग्री 3? कधी म्हणतो आपण U होमोजेनियस आहे डिग्री 3? इफ I U मला कसा लिहिता यायला पाहिजे? x raised to 3 into function of y by x. x raised to 3 into function of y by x. इथे मला इकडे log च्या बाहेर x raised to 3 लिहिता येतं का? हा x cube इकडे डायरेक्ट लिहिता येतो का? येईल का? log चं काय? log ला कसं उडवायचं? उडूच शकत नाही ना, मध्ये आहे ना तो.
हो मॅम.
बरोबर, त्यामुळे या log ला इथे घेऊन गेल्यानंतर मी लिहिला x cube. पण इथे नेल्यानंतर हा फक्त u राहिला नाहीये. व्हॉट यू गॉट इट? e raised to u. म्हणजे हे नवीन फंक्शन झालं जे होमोजेनियस आहे. बरोबर ना?
कळालं मॅम.
So e raised to u is homogeneous, and that's why we have to use the second Euler's theorem and not the first one. And n into u ना, n into u ना. मग तुमचा आन्सर येणार 3 into e raised 3 into तुम्ही लॉगच घेणार पूर्ण. मग ते तर ऑप्शन मध्ये नसणारच आहे फॉर शुअर, आणि असलं तरी चुकीचं आन्सर आहे बिकॉज यू कॅनॉट टेक x cube आउटसाइड नाउ. ओके एव्हरीवन?
Ma'am, g dash of u 0.
Ha. G is what? G is n into f of u by m dash of u. So f of u is e raised to u. Derivative of e raised to u is also e raised to u. So that is getting cancelled and the value is coming out to be 3. Now I want to differentiate this with respect to u. G dash of u means what I told you. It's a derivative with respect to 3. With respect to u, sorry. But even if it is derivative with respect to x, it was other in general. Then what's the derivative of a constant?
0.
0. So it is g dash of u is 0. And that's why this g of u, which is 3 minus 1, will become minus 3. This is totally the formula what we had written. G of u into g dash of u minus 1, where what is g of u? G of u is n into f of u by m dash of u. You please listen all the steps carefully whenever I am explaining. All of them are following one after the other. So if you skip listening to what is g of u, then you won't be able to understand how we are getting that minus 3. Okay, constant derivative is 0 and the differentiation is with respect to u, not with respect to x, not with respect to y. That's why g dash of u means j का u चा function मिळेल त्याचा derivative with respect to u. Okay?
मॅम.
Clear?
Yes.
Okay. Now you take down the next question and you try to solve and see whether you are getting the answer to be what you say, whether it is directly homogeneous or f of u is homogeneous. Take down the question. U is equal to cosec inverse of x raised to half plus y raised to half upon x raised to 1 by 3 plus y raised to 1 by 3. Now this function which is there, till now usually in the university exam this question was definitely asked entirely for first order derivative as well as second order derivative. But right now I think so degree will be asked. And secondly, degree given, they'll ask you the first order derivative. Second order derivative, you can be able to solve it, but it won't be asked most probably in your final exam. So let's try to solve this. Clearly, you can see that the degree of the numerator and denominator are different.
Yes, ma'am.
Okay, half is there in the numerator, 1 by 3 is in the denominator, and you have square root also. So forget about cosec inverse. Can you tell me what's the degree of this expression? Square root of x raised to half plus y raised to half upon x raised to 1 by 3 plus y raised to 1 by 3. Find that first. Then we'll go to the actual question later on. Try.
1 by 12.
1 by 6.
1 by 12 is the answer.
1 by 2.
1 by 12.
Yes, ma'am.
1 by 12, ma'am.
Everybody is getting it. Please,
Yes, ma'am.
I don't want the answers from few students. Okay, everybody should be telling the answer. It is going to be 1 by 12. Just see now how. Those who have got it, go ahead and tell me what is the answer of question. Value of, this is example 2. Find the value of x ux plus y uy in second order also. X square uxx plus 2xy uxy plus y square uy. Those who got the value as 1 by 12, you can go ahead. Just see now how we are getting it. Okay. U is equal to cosec. I'll write down that cosec inverse later on actually. We have x raised to half plus y raised to half upon x raised to 1 by 3 plus y raised to 1. So your expression inside the bracket, the bracket च्या आतमध्ये जे फंक्शन आहे त्याची डिग्री फाइंड करताना what are we going to do? It is x raised to half ना. Square root means what? To the power half. So what will take common? What will take common in the numerator? let this cosec inverse be outside only.
X
I'm
raised
going to
to
take x raised to 1 by 4 outside because it is half raised to half. So half into half, which is 1 by 4. What will remain inside? It will become 1 plus y by x raised to half. In the denominator, I take x raised to 1 by 3 raised to half, means 1 by 6.
1 by 6.
समजते ना सगळ्यांना? 1 by 3 raised to half म्हणजे half into 1 by 3, that is 1 by 6. Into square root of 1 plus y by x raised to 1 by 3. And that is cosec inverse of, what is this? This is x raised to 1 by 4 minus 1 by 6 into some function of y by x. So that is, this cosec inverse will always remain in middle. हे मी परत इकडे जे काय व्हॅल्यू x ची येणार ती कोसेकच्या डाव्या बाजूला लिहू शकणार नाही. I cannot write towards the left of this cosec inverse this expression because it is non-zero. X to the power, how much is this? 6 minus 4. That is 2 by 24, which it is 1 by 12 into some function of y by x. So I have to take this cosec inverse on this side and then it will become homogeneous. So cosec of u is equal to x raised to half into some function of y by x is homogeneous of degree 1 by 12.
Ma'am,
What is it?
ma'am,
Yeah.
ma'am, it is 1 by 12.
Yeah.
You write 1 by 2.
Got you.
Okay. X raised to 1 by 12. Okay. X raised to 1 by 12 into f1 of y by x. So it is homogeneous of degree 1 by 12. Who is homogeneous of degree 1 by 12? Cosec u and not u. Therefore, you are going to make use of second Euler theorem. Function of homogeneous expression. So what will be your answer then? First order is n into f of u by f dash of u and so x into ux plus y into uy is equal to n into f of u divided by f dash of u. What is n? N is 1 by 12. What is f of u? Cosec of u. What is derivative of cosec of u?
Cosec
Minus
into
cosec.
Minus
into
cosec u
cot.
into cot.
Minus
cot.
So minus cosec will get cancelled and you will get this to be 1 by 12 with minus sign n of u. Minus 1 by 12 n of u. Okay. So your first order answer is x ux plus y uy is equal to minus 1 by 12 n of u, which is nothing but g of u. Which is nothing but g of u. So what will be g dash of u? Tell me. You can put in the chat box also. What will be g dash of u?
minus x
Minus 1 by 12.
Minus 1 by 12
square.
secant square.
Minus 1 by 12 is constant. It will be remaining as it is. Derivative of f is secant
X
square u.
square u.
X square u.
Secant square.
That is your answer. And therefore, the expression x square uxx plus 2xy uxy plus y square uyy turns out to be g of u is minus 1 by 12 10 of u into g dash of u is minus 1 by 12 6 square u and minus 1. Okay, now they may give you value of this in terms of tan theta. Value of this in terms of tan theta is. So what you'll have to do for that? Substitute secant square as 1 plus tan square. Tell me that expression. Final answer is in terms of tan theta only, tan u only. So put sec square u is equal to 1 plus tan square and simplify the inside bracket, you will get the final answer. Should I have this part, this question? Because they give you the options. Depending on the option, you have to change the expressions. So this is equal to minus 1 by 12 tan of u into bracket minus 1 by 12 sec square u is 1 plus tan square u minus 1. So taking minus sign common, you get 1 by 12 tan of u as it is into bracket minus I have taken common. So it is 1 by 12 plus tan square u by 12 minus if I have taken common, so it will become plus 1. Taking LCM, this 12 will come here and it will become 1 by 12. Yeah, 10 u. 12 into 1 is 12. 12 plus 1 is 13 by 12 plus 10 square u by 12. That's your final answer.
Plus 10 square upon
In
12.
last year, they were asking you to prove it this. Prove that x square ux plus 2xy uxy plus y square uyy is 1 by 12, 10 u, 13 by 12 plus 10 square u by 12. And now if they will give you this g of u is minus 1 by 12u, then what is the answer of second order? So g of u is this, so g dash of u is have to find and simplify and write it in this form. Is that okay?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah,
Yes, ma'am.
fine. So I'll give you one or two examples more on this so that you get used to it, which one to use when. And now I'll give you mix. So you have to identify which theorem you want to apply. First example is u is equal to log y minus log x. Then find x ux plus y uy as well as x square uxx plus 2xy uxy plus y square uyy. Second is u is equal to sine inverse of root x minus root y upon x plus y. Then find x ux plus 1 and x square uxx plus 2xy uxy plus y square uy. Find out this values. Both the questions. Discuss within yourself if you want and try to tell me the correct answer.
1 and minus 1.
First one is 1. First question you are telling me, na? And the value of expression of degree 1. This one. Oh,
Yes.
I don't think so. Check once again.
First one is 0.
Zero, ma'am.
First one is 0.
First one is
Zero.
0.
Degree
First one
minus
is yes, yes. So just see how. Minus 1 you must have taken because y is equal to minus to 1. That's why you're not talking with that. But what is log a minus log b formula? This can be converted to log y by x, na?
Yes, ma'am.
Isn't it? Even if you go by second formula or you go by first formula, if you want to take this log this side, okay, or you keep it as it is only, what is the degree of this 1 minus 1? 0, na? What is the degree
Yes,
of
ma'am.
this? It's
Zero.
degree 0. So you can write x raised to 0 here, or you can write x raised to 0 here because it is x raised to 0. So what is the most important thing that you have to take care? If your u is function of function, internal function, if it is of degree 0, directly it is homogeneous. Yes?
Yes, ma'am.
So u is homogeneous because this can be written as x raised to 0 into log of 5 by x. And therefore, x ux plus y uy is equal to 0 into u, which is 0. And second order x square uxx plus 2xy uxy plus y square uyy will be 0 into 0 minus 1. So that is so what is the first thing that they'll ask you? What is the degree of this function? Is it homogeneous?
0.
So this is homogeneous function of degree 0. And therefore, first order partial derivative as well as second order partial derivative will be 0. If you had to prove it without using Euler theorem, you'll first find ux, then you'll find ur, you'll multiply by x, multiply by y, and then all the terms will get cancelled and you'll say that the answer is 0. But Euler theorem has made it so simple that within one line you get the answer. Okay? Now think about the second one. What are you going to do?
Ma'am, minus tan u by 2. First one answer.
First answer, no.
Yes, ma'am. Minus 10 over 2.
Yes, ma'am.
Okay, okay, okay.
Yeah, ma'am.
So what it will be? Now degree of numerator is half. Yes, any question? Degree of numerator is half, degree of denominator is 1. Root x means half. X raised to 1 means 1. So what will be the degree? X raised to half minus 1 into some function of y by x. So that is minus half. X raised to minus half some function of y by x. So who is your f of u? f of u is sin u. So x ux plus y uy will be nothing but n into, that is n is minus half, n into f of u. What is f of u? Sin u. What's the derivative of sin u? Cos u. Somebody said it is plus, it is minus. So answer is minus half tan u and not plus. Is it okay? Is this clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So x ux plus y uy is minus half tan u. And what will be this? I'll directly write down now the answer of second order. Second order partial derivative of Euler theorem. That is x square uxx. I'll write it on top. X square uxx plus 2xy uxy plus y square uyy is g of u into g dash of u minus 1, which is, what is g of u we've got? This is g of u. So minus 1 by 2 tan u, and derivative of this is minus 1 by 2 secant square u minus 1. So again, if you want, you can take minus sign common. It will become 1 by 2 tan of u into sec square u by 2 plus 1.
Plus 2 upon 2.
Otherwise you can write 3 upon 2. Tan square u plus 3 by 2. That also you can write. Okay?
Yes.
That's your final answer. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now, if that sine inverse was not there and sine was there, still there is any difficulty to solve it? If this was not sine inverse, it was just sine.
No, ma'am.
Then also the degree is half, but when I take sine on the other side, it will be sine inverse u.
Sin inverse u.
Is it okay? Then you have to take the derivative of sine inverse u, and then what is the derivative of sine inverse u? 1 upon?
1 upon under root 1.
1 upon
Yes,
under
yes.
root 1 minus.
1 upon 1 minus root of 1 minus u square. Okay? That you have to use and you have to substitute. That's it. No a big difference. So right now we have inverse. If inverse was not there, then if it is plain trigonometric function, when it goes on this side, it becomes inverse function. That much care you have to take. Okay? So is this clear to everyone?
Yes, ma'am.
Now I'll ask you one question. This is an MCQ question which is there in one of your reference book. It's not an MCQ question. They have asked, they have given some questions and they have asked, verify which of them are homogeneous and non-homogeneous. So you may be asked in your MCQ exam such type of question. Take down. Identify which of the following is an homogeneous function. Identify which of the following is an homogeneous function. So why I am giving you this question? Because there are some functions which are not homogeneous. That's why there is need of solving the questions of partial derivative by some other techniques also. If it is homogeneous, then we can solve it by Euler's theorem for this type of partial derivatives. But if it is not homogeneous, then a normal method of partial differentiation has to be applied. There are some functions which cannot be solved by your normal partial derivatives also. Then there is numerical methods that you are going to study in M3. So let us right now I'll give you the question. Identify which of the following is homogeneous function. So the first one is x plus y upon xy plus x raised to 2 by 3 e raised to x by y raised to minus 5 by 3. This is your first function here. Second function is x raised to 1 by 3 y raised to minus 2 by 3 plus x raised to 2 by 3 y raised to minus 1 by 3 is equal to 8. Third function is 1 by x raised to 5 e raised to y by x, and fourth is none of this. Which among these four is an homogeneous function?
Second.
Okay. Everyone? Is the answer second?
Yes.
Please once again check it properly. What's the degree of, why the first one is not homogeneous? Let's start in that way. First one is not homogeneous because Why first one is not homogeneous? Quickly, please. Why first one is not homogeneous?
We cannot separate out the e raised to x by y term.
Yes, e raised to x by y term, even if you cannot separate, that is fine. If this was in this was here, it is not there only. E raised to x by y is not there only. That's the first thing. Secondly, when you multiply this y raised to minus 5 by 3 inside, degree of this term and degree of this term is different. Isn't it? If you want to say that u is homogeneous, the degree of each of the terms should be same. Na? What's the degree of this
Ma'am,
term?
so fourth one, none of these.
Only one student had given me the correct answer. This is 1 and this is 2. Degree of this is 1, degree of this is 2. So this expression has degree 1 minus 2, that is minus 1. And minus 1 and minus 5 by 3. You have to multiply it inside. Na? Minus 1 and minus 5 by 3 will become minus 8 by 3. So degree of the first expression is minus 8 by 3. Correct? Everyone? Are you getting it?
Yes,
What is
ma'am.
the degree of second term? Yeah. What is the degree of second term? E raised to x by y is a function of x by y. E raised to x by y is a function of x by y. So degree of this term is 0. Degree of this term is 2 by 3 minus 5 by 3. So how much is that? Minus 3 by 3, which minus 1.
Minus.
Yes.
So this term has degree minus 1, this term has degree minus 8 by 3. They are different. So u is not homogeneous of one unique degree. It is sum of two homogeneous functions on its own. Is it okay?
Yes, ma'am.
Same thing you have to do about second one also. You have got confused. Just see. This is plus
Minus
2
1
by
by
3,
3
this
and
is
plus
minus
1
2
by
by 3. So this is 1 minus 2 by 3. 1 minus 2 by 3 is minus 1 by 3. And this is 2 by 3 minus 1 is plus 1 by 3. So degree is minus 1 by 3 and plus 1 by 3. It's not same. So second is also not homogeneous. Are you getting it?
Yes.
Yes, ma'am.
Please don't run to the conclusion directly. Look at the powers and find out actual value. Add them up and see. First one is minus 1 by 3. Second one is plus 1 by 3. So again, u is not homogeneous. This is very simple. This is e raised to y by x. So degree of this term is 1 minus 1, 0.
Yes, ma'am.
What is the degree of this? Minus 5. So I can rewrite this as x raised to minus 5 into some function of y by x. Therefore, this is homogeneous of degree 5 minus 5. Isn't it? So none of this is also not option. Second one is also not option. First one is also not option. Third is the answer. Is this okay?
Yes, ma'am.
So please be clear with the concept. You should be able to write the given function as x to the power into some function of y by x. This is already a function of y by x. So don't do anything with it. 1 minus 1 degree is 0. So it will be of degree 0. So I write x is to 0 here or x is to 0 here. No problem. But this term which is extra has degree minus 5. Therefore it's a homogeneous function of degree minus 5. Okay?
Ma'am, can you explain first option?
Yeah. First option, I'll just write down this is the first function f1 and this is the second function f2 along with e y raised to minus 5 by 3. Okay. So what's the degree of f1? Numerator की degree 1 है. Denominator की degree 2 है. Correct ना? And outside degree is minus 5 by 3. Isn't it? Y raised to minus 5 by 3 has to be multiplied, na?
Yes.
Yes, ma'am.
So what will be the first f1 degree will be 1 minus 2 is minus 1 minus 5 by 3, that is minus 3 minus 5 minus 8 by 3. Okay, and what about f2? F2 has the degree 2 by 3 plus 0 minus 5 by 3. Powers में जो भी degrees है that we are going to add. So what will be the 2 minus 5, that is minus 3 by 3, which is minus 1. So this degree and this degree, they don't match. They are not equal. So it is not a homogeneous function of a unit degree. F1 is separately homogeneous, F2 is separately homogeneous. But have they asked like that? No, they have said which of the following is homogeneous. So U is not homogeneous because I cannot write what I want to write. X raised to minus 8 by 3 I want to write, or x raised to minus 5, 1 minus 1 is written. And then inside function, will it be y by x? No. It will have only x term, it will have only y term, something like that. Is it okay? That's why it is not homogeneous. Same way, second way. Clear?
थर्ड वाला सांगताल का?
e raised to y by x. Degree of y is 1, degree of x is 1. So 1 minus 1, 0. So this expression, third example, that has degree minus 5 plus 0. And that is minus 5. So directly it is homogeneous of degree minus 5 because I can write x to the power minus 5 into this function of y by x. E raised to y by x is a function of y by x. So it is of degree minus 5. Is it okay?
येस मॅम.
मॅम ते फर्स्ट वाला सेपरेट होमोजिनियस आहे का?
हां, सेपरेट तुम्ही जर त्याला f1 म्हणलं आणि f2 म्हणलं तर ते सम ऑफ होमोजिनियस फंक्शन असं म्हणू शकता. सो आय विल राइट u to be equal to b plus w and then you can think about its partial derivative. But right now it is asked whether u is homogeneous or not. But it is not.
Okay.
Fine?
Yes, ma'am.
Okay. So that is all about Euler's theorem, homogeneous function. Then how do we apply it? And there are many more examples which I have given you in the theory questions. Please go through them. Okay. And very important part is you'll be asked in this for your final exam. They'll ask you not entire proof. They'll ask you what's the degree of this homogeneous function, whether these functions are homogeneous or not. If the degree is 3, what is the value of x to x plus y u r? If the degree is 4, what is the and g of u is 1 by 12 10 of u? Then what is g dash of u? Because it will be a 1 mark or 2 mark question. So lengthy questions you should know because those only will be broken into parts and will be asked. But while solving for your practice examples, try to see that you have to solve these short parts. Clear? Yes. So let's go to the next topic now. That is composite function. And that will give you almost, it will be the second last part, composite function and then total derivative. That will give you an insight of applications also of partial derivative. So let me write down composite function.
Excuse me, ma'am.
Yeah.
Before that, I would like to solve a class problem. Can I?
Yeah.
Ma'am, I don't want to be CR anymore.
Okay, fine. We will talk about this in 5 minutes. I'll just explain this and then I'll tell you. Okay?
Yeah, sure, ma'am.
Yeah. Yes, composite function. What do you mean by composite function? It will be function of function. Composite means what's the literal meaning of composite? Composition.
Addition or together function.
One function inside the another function.
Yes.
One function inside the another function. So that only is the meaning of this composite function in mathematics also. Suppose you have u, which is a function in xy, and xy is further a function in t. U is a function in xy, and xy is function again depending on t. So tell me what will be the derivative of u with respect to t? Whether it will be ordinary derivative or it will be partial derivative. Whether it will be an ordinary derivative or partial derivative. Okay, let us write down. Del by u by del by t. Del by u by del by t. Since you are saying it is partial derivative. What will be the value of this? How can I reach to t? What are the different possible ways of going to t? Can I directly find the derivative of u with respect to t? Can I directly go from u to t? And यहाँ से यहाँ मैं jump कर पाऊँगी क्या directly? तो फिर x और y लेने का कोई मतलब ही नहीं था ना?
Ma'am.
Yeah.
Del by u by del by x into del by x by del by t while y is constant.
Correct. Plus, this is what is the most important part. सिर्फ u x पर depend है और x t पर depend है ऐसे है क्या? नहीं ना, u y पर भी डिपेंड है और y t पर डिपेंड है. तो वो भी प्रॉपर्टी यूज होनी चाहिए ना, u डिपेंडिंग ऑन y. तो देयर आर टू वेज. आइदर यू कैन गो फ्रॉम u टू x and then from x to t, or you can go from, this is one way. Other way is you can go from u to y and then y to t. Are you getting it? समझ में आ रहा है क्या? This is called a chain rule for composite function. There are two ways to reach to t. U से x तक जाओ, then from x you go to t, or go from u to y first and then from y to t, because y inside has t as well as x inside has t. So your chain rule for composite function will be deriva u by deriva t is take the derivative of u with respect to x into x with respect to t, or this is one way here, and then u with respect to y and y with respect to t, that time x will be constant. Okay, fine.
It is a ma'am.
Yeah.
Ma'am, it is a just like a chain rule or else?
Yes, it is chain rule only. Composite functions, partial derivative of composite functions are found with the help of chain rule. This is chain rule only.
Yes, ma'am. Okay.
Okay, fine. Now, only one thing I wanted to ask you, which I started only with. I asked you whether u will have ordinary derivative or partial derivative. When do we use partial derivative? Partial derivative का statement ही हम लोगों ने कब use किया था? जब u more than one variable पे depend होगा. Independent variable will be more than one. बीच में है दो variable. लेकिन finally कितने variables हैं? How many variables are there at the end? Only one. So when I'm finding the derivative of u with respect to t, it won't be partial derivative. It will be ordinary derivative. Are you getting it?
Yes, ma'am.
Yes, ma'am.
du by dt will be found with the help of deriva u. Or it will be deriva u because what is the thing? What is the thing here? Deriva u by deriva x. That time what should I do with y? That will be a question. So u with respect to x taking y constant. Again x is only depending on t. So here also it will be dx by dt. Is this okay? There is no y here. x अकेला t पर depend है. x यहाँ पे t और r है क्या? नहीं. So that will be dx by dt. U with respect to y will be partial and this will be dy by dt. So it is a mixture of ordinary and partial derivatives. Are you getting it?
Yes.
मॅम यू दोन व्हेरिएबल वर डिपेंड आहे ना पण मॅम?
हो ना, म्हणून partial घेतलाय ना. पण अल्टिमेटली जो व्हेरिएबल t आहे तो एकच आहे. तर फायनल जो डेरिव्हेटिव्ह येतो तो partial तो असं लिहू शकतो deriva u by deriva t, but that is actually ordinary derivative because ultimately there is only one variable.
Okay,
is this okay? And middle one when I'm doing, I have to use deriva u by deriva x because there is one more variable. What I have to do with that? Take it as constant. But dx by dt, no other variable here, so ordinary derivative. U with respect to y, yes, partial derivative because x is there. What should I do with x? Take it constant. And then x with respect to t, y with respect to t, that is ordinary derivative. This is a special case because finally you are having only one variable. If here there was one more variable, then all of them would have been partial derivatives only. So that will be the most prominent part of composite functions. So I have started with a simple one, wherein it is mixed of partial derivatives and ordinary derivatives, because ultimately there is only one variable. Okay, fine. We'll go in more depth in the next lecture. For this, let me take the attendance and then division D, we will solve the problem. Okay, just a second. Yeah.
Ma'am, can you explain how it is different from our normal derivative?
Yeah,
normal composite derivative.
Yeah, just a second. No? What you said, how it is different from?
Normal composite derivative.
What do you mean by normal composite derivative? That's chain rule only, na?
Yes, ma'am.
You're saying na chain rule only, na? Yeah, see, your chain rule, where it is like this: u is a function of xy, and xy is a function of r and x. Okay, that time, if you want to find the derivative of u with respect to x, u with respect to r, everything will be in terms of partial derivative because there are more than one variables. And here also, u with respect to xy, xy with respect to t, middle there are two variables, so you are going to get half of them partial and finally get ordinary derivative. The chain rule that you have seen was u depends on x and x depends on t. There was one variable only. Independent variables were only one, isn't it?
Yes, ma'am. Yes.
Yes, the student who asked me that doubt. Your ordinary derivative chain rule of composite function, u was depending on x and x was depending on t. So du by dt would have been just derivative of u with respect to x into derivative of x with respect to t. So everything is ordinary derivative because there are only one independent variable. But now either in middle there will be two variables, or at the end there will be two variables, or both the places there will be two variables, and therefore depending on how many variables are there, it may be a composition of ordinary and partial, it will be a composition of all partials, or if it is depending on only one variable, it will be ordinary derivative. Is this clear? This is also chain rule. This is also chain rule, and this one also will be chain rule. So u with respect to x, x with respect to r. Here y will be constant. Here s will be constant. Or this is one way to go from u to r with the help of x, or you can go with the help of y. So u with respect to y, that time x is constant, and y with respect to r, that time s is constant. Is this clear?
Yes, ma'am.
Okay. I think Anjali it was.
Yes, ma'am.
Yeah. So in your ordinary chain rule, all of them are having only one independent variable, so everything is ordinary derivative. If middle variables are two, final there is one, so it will be a mixture of partial and ordinary derivative. If middle also there are two variables and finally also there are two variables, then the chain rule will have all partial derivative. Variables which are in middle, if I am differentiating with respect to x, y will be constant. If I am differentiating with respect to y, x will be constant. And when I am differentiating x with respect to r, which is the other variable s, that will be constant. When I am differentiating y with respect to r, then also s will be constant. Okay? Clear? So what will be this question? This will be asking. What is the ordinary derivative? What is the derivative of u with respect to t? What's the derivative of u with respect to r? This formulas will be asked. So you should know that if I want to reach from u to r, there are two ways to do. From u to x, x to r, or u to y, y to r. Or is always represented by addition and n is represented by multiplication. This you have done in your electronics gate also. Whenever you have or, it will be addition. If it is and, it will be multiplication. Here it is what? And. So I am writing multiplication. U with respect to x and x with respect to t. So u with respect to x and x with respect to t. So product. And here it is one product we have already done. U with respect to x and x with respect to r. So product. Or u with respect to y and y with respect to r. So middle plus again product. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay, so that's about the beginning or starting part of composite function. Now we'll write down all these formulas and examples. We'll also see on this in the next lecture, which is third one. Okay, fine. So 131 students are there, and they'll be marked present. I'll take the attendance again in lecture number 3. That time both the combined ones I'm going to consider. Okay, the students who have attendance less than for 40 minutes won't be marked present. Just a second. Let me stop the recording.